You are indeed correct, Mr. K9. The probabilities continues. There was something that we could factorize, I think. Maybe we need the full picture. Because they're all divided by... They are all divided by z. Now we're getting somewhere. So this is really a sum, huh? Like what you see, yes. Yeah, it's much context, but I think you could see some of the math stuff like that Mm, yeah, the product symbol, that's just that you get some e's multiplied together. But when you get e's multiplied together, that's the same as saying that they have the same exponential. So this is really a sum. But what kind of sum? Is it a squiggly sum? Or is it a normal sum like that? I think it's a squiggly. It must be a squiggly sum. And this is really the same as this. Because they... If you... Oops. If you take the product symbol back inside, then this sum becomes a squiggly sum. So now this explains why we had this weird Mongolian stuff. Like this big chungus. That's awfully a lot like mine. I don't know why this A is. So we needed a fresh brain to understand it. Or at least a fresh brain helped. But... Ooh! But don't this just... factorize to 1? Oh! But I think we're close though, but it looks like awful lot like 1 to me again. A phase of evolution, and every equation is a principle of how we are today and determines what the generations will look like after a century. Will semper fi. Yeah, maybe it's a bit like the time-dependent Schrödinger equation. I have this annoying 30 minutes timer auto shut off on the camera. And I think it's because it was like invented so that people can't set up a tripod or something with the camera and record a movie. Because it's a high resolution camera. And also they capped, I think they capped the resolution for live view. Maybe also so that you can get high resolution recording of a movie, like bootlegging. Oh, maybe it's not a recording, but it's no, it wasn't bootlegging. It is some rule that you can't broadcast. That's what it was for. Because it costs a fee or something to, and you need to have like a broadcasting. Oops. Where is it? There it is. It wasn't because of bootlegging, but it was so that you can't stream. Like if someone wanted to make their own, I guess these rules were applied before YouTube and Twitch. Motivates me, yes. We are just like Richard Feynman right now. We are a chimpanzee staring at the banana, and the banana in the tree, and the banana high up in the tree for us is how we can massage this equation to something that is not 1, that is not equal to this. But how doesn't this cancel this? They're so similar, they're basically equal. And right now, we are just like that chimpanzee Richard Feynman talked about. Or he said he feels like one as well. Because we're trying to put the sticks together so that we can knock down the banana high up in the tree, because we can't reach it with our bare hands. And now, maybe this is wrong. No, this. And this, and this. They're all divided by z. And it really should be, just by pure logic, we saw that this was 1 times 1/3 plus 1 times 1/3 plus 0 times 1/3. Welcome, Sec Labs. Don't know what you're looking at. Well, I'll feel the same. Yes, 𝐏𝐭, maybe there's some tricks there. Some exponential tricks, maybe. Hello, Mr. 𝐒𝐭𝐮𝐬𝐢𝐚. Sorry for a late reply. Mr. Sack. Yes. You're taking Calc Ab M. Calculus. Yes, that's a good start. Then you'll get your complex number knowledge up. It would be good, well, for this, the math in statistical mechanics is very, I don't know the terms for it, but it's, but in a layman language, it's much integrals. And yes, Mr. Kuzmino from Twitch. Oh, Semper Fi, yes. I'm in the Norwegian Armed Forces. Not full-time, obviously, but like a reservist. And it's much integrals. And statistics, yes. And to get into the stuff you could get if you just start with thermodynamics. That's probably the first course that's like statistical mechanics, because they are really the same. But statistical mechanics is kind of a nitty-gritty version of thermodynamics. Thermodynamics is a bit more wavy, and it came first. It's like they had the postulates of some rules that they saw by experiments in of the universe. And then they think, okay, nature behaves this way, it seems like always, by the experiments. And then they postulated that this and this must be true. And then they derived some equations out of that. But statistical mechanics starts at an even lower basis. Not to make bombs, no. To develop quantum technology. And I wanted to start. There was so much interesting to study, but I thought physics maybe was the most fundamental. Well, you too, Mr. Sack. I will probably be here when you are looking. K9 is eager. But this can't be right. I must do some research. 𝐏𝐭./𝟏🟏, you should check out quantum computers, semiconductors, solar cells as well. And condensed matter technology, maybe, like sensors, light, LEDs. See you soon, Sack brother. You'll be back. You're referring to the equations I wrote, K9? Oh, yeah, I understand. Yes, sir. Yeah, looking through old notes, that's not easy. I think this is true. But maybe this is wrong. Son of a gun. Yeah, that. But times 1 times 1 times 0. Pick level epsilon 1 110. So maybe my n epsilon is wrong. Maybe this is not 1. Oh, it is this. But this is 1, yes. And this is 1 that we knew, but what we didn't factor in is that here n1 is 1, n1 is 1, and n1 is 0. Do, do, do. Oh yeah.
Yes, science!
Yeah, Jesse, you're right. So it can't be this, right? Yeah, the NE has to really be inside. Or else that's mumbo. It's a mambo jumbo. But how do you write that? And how do we write this as a generalized way? Obviously divided by z. We don't get rid of that fast, at least. Mr. Taylor. You should be really good at Taylor expansions, I presume. They are widely used in this course. So much that I'm getting a bit used to it. Switch the sum and product. Yeah, you mean in the partition function? Down here, so you can see that it's sort of equal. What's a little bit weird is that an epsilon it's a weird notation, but this can't really be pulled out of the sum. So now we actually got it. Sort of. Because this is just like Svensson uses also this formula right here. Here, this big boy. He says if you just pull the beta outside, he says that this is this, which is now what we also have. Yes, but just with epsilon instead of alpha. It's weird, but that's the problem's notation, unfortunately. Looks like the green function? I think I remember my professor mentioning the green function in the beginning of the course, but he never did later on. And I had the green functions 1 year ago, of course. And we all, or I at least, am very familiar with my non-functioning memory. Laser. Oh yes, quantum indeed. EE side, roger that. What's the EE side? Electro emission? No. Electric essence. Electrical engineering, of course. Do you have to work a lot with is it polarity it's called? Or at least yeah, isn't it polarity? No. Integrated photonics. Is it and what's the photonics or lasers used for? Like, see if I can remember some. Not atom sputtering, right? No. Ah, cool. Can you also say that it's optics you're working with? Yes. Now I'm starting to wonder, isn't this notation a bit wrong? Diodes, yeah. It doesn't take long before it becomes complicated. Start with one simple thing, and add another simple thing, and another, and another, and another simple thing, and suddenly you got something complex. Special functions. But this thing looks really ugly. And it's this I'm looking for. Because I don't understand. How could it be n alpha there? Because if you want, let's say alpha is 1, and this is a sum. Where did the product symbol? Okay, he has he has done some simplifications. Beta, it's just the Boltzmann coefficient. No, that's not the word for it. But at least it's 1 over kBt. Mu is the chemical potential. So in some way I'm supposed to get this from my expression. I can probably pull out. I can probably do this. And I'm using epsilon instead of alpha. It's a worse notation, but my problem uses it, and my professor.
Liar.
So I have to do it as well. And the partition function was epsilon. The epsilon is a little it's a little mind calming factor that I introduced, because this big epsilon is not the epsilon. This is not the epsilon index. So I put the index there because this is the energy level. It's a value like minus 13.7 electron volts or milli electron volts. So this is the index, and this is the energy of that energy, and the index is energy state. You know, your particle can have a ground state energy, and then some other energy states up here. This is probably, I think it's milli. No, something like this. So this would be the index, and then you have the big here equals the value. But there should be something we could maybe it's like we just cancel this. I think. Ooh. Yeah, there's gonna come some conduction band and valence bond in here. Luckily for me, since I'm doing condensed matter physics, I was very lucky that statistical mechanics, at least the professor introduces some condensed matter. Oh, Rydberg, I don't remember. Rydberg constant. Something, yeah. But now this epsilon is just sorry for the mess. So I guess now I have actually the same as the book. Oh. What happened now? I think he actually should have said that this. He should have done like I did, then said it's the alpha prime. Because this is supposed to be only the one value. And n is amount of particles in a state. And if you have fermions, there can only be one in a state. And of course, it's like we know that fermions can have, there's two levels, spin up and spin down. That but spin up and spin down is actually its own energy state. But it so happens to be that two energy states gives the same energy value. But really, if you're nitpicky, one state is purely described by all of its components, so spin and position and energy value. So even if the spin is different, then you must technically say that it's a different energy state. Yes, surprisingly, the new models of ChatGPT, I like to call it Oracle. It's very good to find, because I guess there's so much literature out there that it's really heaven for ChatGPT to scan through, I guess. It's very good at understanding intermediate steps that's been done, and also finding errors maybe in. So I think if I would put this expression inside the Oracle, it would say that maybe this should be alpha prime, alpha prime, alpha prime, alpha prime, alpha prime, and that this is just the normal alpha of here. It's very good at that stuff. And also if I would plug in this expression and just ask what in the name of Mother Nature happened from the first line to the second line, it would like explain, yes, you do this and you did this and this, that's the sum, and then you take the ln, You could really flesh out the steps. But it's what it's not good at, that's finding the answer itself. Or it's at least worse at that. So if I would just say, I would just give Oracle this and tell it, okay, what is this? Then it probably, this is just some this is maybe a bit easy for it, but if there's some values in it, it's not that good at calculations. ln x. Is there some trick? I think there's some trickery with ln x, right? There's not many tensors here. It's a bit weird. I thought it should be more tensors because it's quantum. Maybe they're omitted. But there are usually a lot of tensors in quantum mechanics. But maybe there's like not that many tensors in quantum statistical mechanics like this. But now that we got this, what more can you do with this? No, I haven't tried DeepSeek. Maybe it's better than ChatGPT. Oh, yeah, it's just a geometric series. Yeah, yeah, yeah. You are goddamn right. That's important to remember. I should actually write it down. I try to collect important stuff on the back of back page of my book. This is blank, but don't worry, guys. It's because I had to write in a new book. The other one was full. I can actually use this example. But where did he remove the sum, the product symbol? Shouldn't be a product symbol out here. Holy shit. Sorry. Oh. Yes, and then you see that's a geometric series because every term is just like the previous one times one extra thing. Yeah. And if you take this to the infinity, yes, this was 0. So then it's just 1 minus 0 equals 1 over. Oh, it's not this. Was it plus or minus? Minus, I think. I think it was like this. Yeah, product is the sum in the exponent, yes. But here it seems like they're missing. Because it was a sum in the exponent and they put it down, so it became the product symbol, because this where was I? There it was. Because you started with this, you know? And it seems like he was just taking this for bosons. But what about this? It's just gone. Oh, sorry. I don't know why. Because he's trying to calculate this. So he does what I did on that page, you know. He he's just he wants to find this, you know. But actually there's a product symbol here and a product symbol down here, but they just cancel. So that's why he's just doing some simplification and then trying to calculate this, you know. But this is okay. But what is this? Just out of curiosity. The numerator. Yeah. So that's the thing on top. Okay, enough of that. And what is this? Geometric series is just 1 over 1 minus r. For mod r. Yeah. Less or equal to 1. And that's because this thing is really 0. You know, if you take e to the minus infinity, that's the same as 1 over e to infinity. And that's 1 divided by billions and trillions and millions of millions. And that's 0 in the limit of that big N goes to infinity. And sometimes N doesn't have to go to infinity. If there was something, N could be, yeah, in the what was it called again? In Bloch's theorem. In Bloch's theorem, Galva the wizard has joined us. It's going forward, Galva. It's going forward. We found out the beast. The beast of average value or mean value. Because we figured it out because we knew the power of the squiggly sum. It was really the missing link. Just when I thought it was, he pulled me back in. Yeah, for crystals, yeah. There you have a laws of Bloch theorem. We found the average, the mean value of n epsilon. That is the average occupational number, or average of particles in a epsilon state. They pull me back in. Just have to look. Quick sneak peek at the back at the Fourier series. No, not Fourier. Bloch's theorem. That's good, boss man. That's how it should be. Yeah, the Bloch's theorem had that it was 0. That was a trick. Because when you had the geometric series and you had this wave function that was e to the something with divided by big N, and then you put in n as the upper limit in the geometric series, it was e to the integer, or I pi integer, so that was 0. No, that was 1. And then you had 1 minus 1, so the geometric series was 0. Oh yeah. Mr. Galva, did you see that I had the late night stream as well? I hoped you didn't see it, because I was afraid to scare you away. It was another kind of physics. It was the Force in the Star Wars game. Oh shit. Oh, I'm glad I didn't scare you away. It was Sergeant Blaine. This is physicist Blaine. He's a bit calmer. But he can suddenly become dark. But how on earth can Mrs. S say that it is correct. Is it though? Maybe this is the first time in history Mrs. S is a bit wrong. But I've said that many times and proven to be myself wrong. She says it's this. Okay, at least she has. I think she must have something wrong here, maybe. Or maybe not. But she says this. And I think I would like to do this. She probably means the same, but At least I want to tidy the notation as much as I can, but still not deviating too much from it, so that I won't get mind crumbled at exam. But she says this. And now we see that we also had n here. But actually she says it's this. And I should probably find it, but it said that it's a fact that the sum is like this, or of this. So that's a fact. But so what she actually said was this. I'm not sure if she means this or this. Yes, it's indeed a written exam. That's why I'm tasking and tasking and tasking. Total average number of particles is equal to the sum of the average number of particles in each state, epsilon. Yes. I haven't proved why yet, but I am gonna see if she used it. Mrs. S. She has made some notes of the solution to the problem that I'm trying to understand. You see, there should really be a solution to the solution, because it's so damn difficult.
Yes, science!
But this is what she wrote. But I think she means this. Maybe we can see why this is true very quickly. Probably not, but let's give it a shot. Just quickly. Yeah. Whoa. Whoa. You got made. No. The exam in my other course is the 28th of May. Oh. 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 hoped it was supposed to be the 2nd of May. No, 2nd of June. That means how many days do I lose? I lose 1, 2, 3, 4. 4 days of practice. Why, nature, why? Oh! It was very fitting with that sad music. Oh! The universe knew all along in space-time. It was destined to happen. But I have a lecture with him 12:15 today, so I'll ask him if it's only 1 day. Yeah, it was 1 day. Ooh. But I'll ask him if it's certain. Well, at least that means that we get more days to practice for the really statistical stuff. Because I have an exam 13th of June. And that. I will be okay, K9. Shall never surrender. Let's see what Swenson says. I agree to you, Mr. Swenson. This is correct. The equation for the average number of particles as a derivative of the grand canonical partition function is, of course, related to the corresponding thermodynamic identity in terms of the Legendre transform of the energy with respect to T and mu. Yes, bring some dark music to this black magic. This is really the dark side of the force right here. Swenson, he couldn't handle himself. He had to use dark side powers to gain this knowledge. It was a dark side and time in history. How on earth is this true? L and Z? I think they're just like playing around with partition function. Partition function was this. So if you take ln of this, you have many terms multiplied together. And when you have multiplication in the logarithm, you get you can your multiplication in the logarithm, you can say that it's a sum, because ln of ab equals ln a plus ln b. But he doesn't use that at all. He says that this is ln z is minus beta u of t mu. Oh. What is this dark sorcery? And then he just said the average number of particles is then this. What? This is gonna be the worst proof I've ever seen. This is gonna be the best pirate I've ever seen. And so it would seem. To me, this derivative of PV of respects to mu, And then just this. That's really, to me, that's just...
Higher.
Oh, but I know another true fact. A better way to show it. Yes. To show this. Because now we know this. You just have to use the same principles. So this is really squiggly sum of what? Squiggly sum of n? Maybe? But at least it's... We know that this is true. Because if you sum up all the particles in each state, you would naturally get how many particles you have. And then it's just this. So then you see you could just pull the sum out. But what is... But how can you change this to the squigglies? So maybe if you pull this sum out here, maybe you then have to change the limits or what you sum here. But how do you change these limits? Thank you. It is really that I've been in it so long that I just accept the pain. Accept the pain. I really have to be like Yoda. Be patient. I can only understand what I can understand. So I guess there's no reason to hurry. Then I won't understand anything. And I probably can't understand everything. Anyways, so we'll try to understand as much as I can. Each day a little more. The Quantum Sergeant. Oh, it's cooking in here. I need to open the window. We need to make an example to understand this. How the average value of n would look like. Yes. Correct. Or how you would like write it. What the expression would look like. And I was crafting some food, so I was so slow. It's really the same as the squiggly sum of an epsilon squiggly, because here, but it's just here you just you're in the for loop you're just throwing in one value, not three values, because here you should use that n1 0, here you should be that it's 1, and here you should be that it's 2. Like this. So it should be but since it's not several values, I think you often just then say that it's we are going up to 2. Then you can just say like this, because it's still the same. So you would normally get this. Obviously it times the probabilities, So how would you factor that? But this is, maybe you could just say that this is just n. But then it's something about... We need to remember that the probabilities are given by the Boltzmann coefficients, or the states, or whatever you should call them. So whenever you have an n, you get different states with which sums up to n, but n can really will be changing. So maybe you can say that the probability is given of n. Yeah, because when n is 0, then it's its own with several of these. Maybe that's the way. Oops. Sorry for the parentheses. The outer one is really not necessary, but since I wrote this ugly one. is not wrong, so it's really this. Let's see if someone else agrees with this. Was it too loud? Was it very loud? I couldn't even hear what I was playing. Didn't have any audio connected to it. It's because I have the microphone connected to the keyboard or synthesizer, because it has a MIDI interface in it, so it can convert the signal from my microphone into something audible. Then I connect the keyboard to the computer, and then you get the microphone sound. Whoa, what was that? Maybe it's just like this. Maybe this one is just P of n. Yeah. I hope it didn't explode anybody's ears, because I have the microphone really amped up. So I guess the piano side was like blowing everything up. And probably distorted as well. So maybe this is like wrong. Switch to that Star Wars cantina music. I always do that when I'm crafting some food. So how can we go from this is where we really start. And how can we turn this into something about an epsilon?
Liar.
A little bit. I think maybe there was some delay, so I didn't play in sync probably. Yes, I am. Plot twist. Thanks, man. And the plot twist is, this is really how I look like. I try to always try to play more by ear than notes, so that I can improvise, you know. But I really play guitar though. That's my main thing. Electric guitar. I would say the oldest favorite of mine is B.B. King. He's been listening to him the most. And then also Slash really needs a place there. Of course, right below, just a nanometer on the scale, is like Joe Satriani and Yngwie Malmsteen, for instance. And of course Eddie Van Halen. I think I resonate mostly with B.B. King and Slash's playing. It's sort of like they're singing through the guitar. Well, Slash goes sometimes very rhythmically as well, but when he is really fluent playing, I like that. It's like his I don't know what's the name in English. Suing? No. Slash sometimes play very fluently, so it's like he's... I'm asking Oracle about the word in English. Embroidier? Embroider? Like he's embroidering, if that's correct. Oh, well, this might be it for today. Unfortunately, this will be a short work day. Oh. Because it's lecture now. In 12:15, so I don't have that good time. And I don't think I will manage to stream afterwards. Maybe in the evening. But at least tomorrow. Then will be a long day. Oh yeah. It's Sunday. Well, you have a nice day too, Galva the Wizard. And if there's anyone else watching, I wish you a good day, ladies and gentlemen. And I'll be back. Goodbye, boss man.